Okay, in this video we're going to be looking at this optimization question, and it follows: a farmer has 2,400 meters of fencing and wants to fence off a rectangular field that borders a straight river. He needs no fence along the river. What are the dimensions of the field that has the largest area? Now I just want to point out from an introductory video that some few key terms I just want to highlight before we start. Largest area. Now that area reflects a rectangular field. So just mentally, okay, it's going to come down to a derivative that involves an area. And the question asks, what are the dimensions of the rectangle? So we just need to keep that in mind of what to expect. Okay, so we're going to draw the diagram to represent what's going on. So it's along a straight river, and the river doesn't need fencing. So the river acts as a fence in itself. So just write river. Okay. And the farmer wants to put in a rectangular fence. Okay, so that's the fence without the fence running along the river. Okay, so the fence features obviously width. For this question, we will represent width with the variable w. So there's another w, and the length. We'll represent that with L. Okay, so we need to determine the dimensions of the fence along the river that would hold the largest cross-sectional area. Okay, so that's sorry, I just bumped the camera. Okay, so that would be your layout of the diagram, and that's probably as much as you would need to draw at this stage. Okay, so following my introductory video where I outlined 7 steps, I'll be following those 7 steps in in attacking this style question of optimization. Now, in the question, we read that we're interested in the dimensions of the field that would produce the largest area. So the question is actually asking, so step 2 would be maximize area. And that's specifically referring to a rectangle. Okay. So the area of the rectangle, we know, is represented by the length multiplied by its width. And as mentioned before, we're going to come down to step 5, and we're going to be taking the derivative of the area with respect to one of these variables. Okay, so the third step is to involve the constraint. And from the question, we know the constraint is 2,400 meters. So he's restricted to 2,400 meter fencing, in which he needs 2 widths and a length, and nothing across the river. Okay, so what that 2,400 actually means is its entire perimeter. Okay, and we know the perimeter of a rectangle is represented by 2 lengths added with 2 widths. And in our case, the perimeter is 2,400, but only with 1 length and 2 widths. And there's only 1 length because the other length is the river, and the river doesn't need a fence. Okay, so now we need to solve for 1 variable, and we'll make L our subject. So by reducing minus 2L to both sides, you'll be left with 2,400 minus 2W. And that's as far as you can go in terms of our constraint. And you've made 1 variable expression by 2,400 minus 2W. And we're going to substitute that as part of our 4th step. And we're going to reintroduce the area expression, the length, which is actually represented by 2,400 minus 2W, and that's being multiplied by W, and if we expand that out, it becomes 2,400W minus 2W squared. Okay, and that's our function. That's the function of the area. Okay, so our 5th step would be to take the derivative of the area function. So the derivative of the area function with respect to its width would be 2,400 minus 4W. Okay, and we're going to set that to 0. So by setting that to 0, we've got 0 equals 2,400 minus 4W. So 4W would equal 2,400, leaving W equaling 2,400 over 4, which is 600 meters. Now, we found 1 variable. So we found what the W would equal. So back to our diagram. When the area is at a maximum, the width would be 600 meters. So we know that is 600 meters, as is the other width. Now we just need to find the length, which is step 6, is to find the value of the other variable. Now we know length from step 3 is 2,400 minus twice the width, which we know the width to be 600. And that works out to be 1,200 exactly. And the width of 600. And using these numbers, the area would equal 720,000 meters squared. But that's not our answer. That would just produce the largest area. It's asking for the dimensions of the field. So what are the dimensions of the field? And the field would have 600 meters width and a length of 1,200 meters. And that would conclude step 7, is to answer the question. So you'd say the Length of the fence would be 1200, and there'd be two widths of 600 meters each. And that's how you would answer this style question.